Well, let us recollect about ellipse. The general equation of any conic section in polar coordinate is given by r is equal to r0 divided by 1 by epsilon 0 cos theta. This equation, where epsilon is called the eccentricity. Okay. In Cartesian coordinate, r is given by square root of x square plus y square, and x is r cos theta. So let us substitute this in equation 1. Therefore, root x square plus y square is equal to r0 by 1 by epsilon x by r, or r0 by 1 minus epsilon x by square root of x square plus y square. So cross multiplying and rearranging, you will get a square root of x square plus y square is equal to r0 plus epsilon x. Squaring, you are getting x square plus y square is equal to r0 square plus 2r0 epsilon x plus epsilon square x square. Rearranging, you will get this equation 1 minus epsilon square into x square minus 2r0 epsilon x plus y square is equal to r0 square. So that is equation 2. Equation 1 and 2 are the forms of general conic section. One is in equation 1 is in polar coordinate and 2 is in Cartesian coordinate, where epsilon is the eccentricity that determines the shape of the conic section. Okay, for the value of epsilon in between 0 and 1, it is an ellipse. Remember, epsilon equal to 0 is a special kind of ellipse that we called circle. Okay, so circle is a special kind of ellipse. That means an ellipse with one focus. Okay, now from equation 1, we can calculate the maximum value of r. The maximum value of r occurs at theta equal to 0. Okay, the maximum value of cos theta is 1. That occurs at theta is equal to 0. Therefore, r max is equal to r0 by 1 minus epsilon. That is the maximum value of r. And minimum value occurs for cos theta is equal to minus 1. That is theta is equal to pi. That is r minimum is equal to r0 by 1 by epsilon. These are the graph that you have to remember. This is r minimum, this is r maximum, this is theta, this is r. Okay, x and y coordinates. Now the major axis is, from this figure it is clear that major axis, that is here these two vertex, is r minimum plus r max, right? So the major axis here to here, a major axis is a is equal to r min plus r max. That is r0, r min is 1 by 1 plus epsilon plus 1 by, so that you will get 2 r0 by 1 minus epsilon square. That is the major axis. Therefore, the semi-major axis, small a is capital A by 2. That is r0 by 1 minus epsilon square. So this is this distance to the origin of the coordinate is called semi-major axis and is given by r0 by 1 minus epsilon square. Now the distance from the origin to the center of the ellipse. This is one of, an ellipse consists of two focuses. One of the focuses is here, another is here. So the distance between the origin O to the focus is called x0. So actually x0 is a minus r minimum. Okay, so that is x0 is a minus r minimum. We know what is the value of a and r minimum. Substituting, you are getting r0 epsilon by 1 minus epsilon square. Okay, remember the eccentricity epsilon is this x0 by a, right? x0 by a. Well, so now we got the eccentricity. Then we want to calculate the semi-minor axis, that is the y-axis. So for that I have this construction. So this is x0, this is r, this is b. B is called semi-major axis. So using the Pythagorean theorem, you have b is equal to square root of, that is x0 square plus b square is equal to r square. From that b is equal to square root of the r square minus x0 square. Okay, that is b. Also cos theta is x0 by r. Okay, so these are the two equations that you have. Now we have the equation for general conic section r is r0 by 1 minus epsilon cos theta, or r equal to r0 by 1 minus epsilon cos theta is x0 by r. Cross multiply and rearranging, r is equal to r0 plus epsilon x0, that is r0 plus epsilon x0 is r0 epsilon by 1 minus epsilon square. So that is r0 into 1 plus, and doing the calculation you will get r is equal to r0 by 1 minus epsilon square. Okay, so now we got the value of r, therefore b is equal to square root of r square minus x0. We can substitute the value of r and x0 that you obtained. You will get b is equal to r0 by square root of 1 minus epsilon square. That is the value of semi-major axis. Okay, so we got semi-minor axis, semi-major axis, x0, r minimum, r max, everything. And one more very important fact is, so this is one of the focus, this is another focus. If you have a construction like this, one r from the other focus r prime, then you will get r plus r prime will be a constant for an ellipse. Okay, so that if you draw from here to here and here to the other foci, so that distance will be a constant. It's a very important property of an ellipse. Okay, that is fundamental property of an ellipse. We can prove it. For that, here we can use this triangle where you, so this is theta, so you can use the cosine rule. Okay, so using the cosine rule, r prime square is equal to, so some calculation, r prime square is equal to r square plus 4x0 square minus that is a square plus b square minus 2ab cos theta. That is the relation, r square plus 4x0 square minus 4x0 r cos theta. Now what I am doing is this one. We have r is equal to r0 by 1 minus epsilon cos theta. From that cross multiplying and rearranging, what I am getting, r minus r0 is this one, r minus r0 is r epsilon cos theta, or r cos theta is r minus r0 by epsilon. I am substituting r cos theta here. What I am getting, this one, r prime square is equal to r square plus 4x0. So r cos theta is this value. Then, and we know x0 is r0 epsilon by 1 minus epsilon square. That I am substituting next. R square plus 4 x0 is this one. So minus 4 x0 r by epsilon, then plus 4x0 r0 by epsilon. So two equations, and rearranging and doing the calculation, what you will get is r minus 2r0 by 1 minus epsilon square all square, that is r prime square. So definitely r prime will have two values, one is positive and another negative. Okay, for which one we should take? We know a is always greater than r. What is a? The distance between the vertex along the x-axis, that is a. A will be always greater than R. Okay, so what was A? A was 2r0 by 1. This quantity is actually A. 2r0 by 1 minus epsilon square is A. So A will be always greater than R. So this will be negative. Okay, square root will be negative. So in order to make R prime positive, we should take the minus. Okay, this is happen because A is greater than R. Therefore R prime is equal to, I am taking the minus value, minus R minus 2r0 by 1 minus epsilon square. So 2r0 by 1 minus epsilon square is A, that is minus R minus A, or R prime plus R is equal to A, that is a constant. That is what we need to prove. So the sum of the properties of ellipse. Okay, so that's very important. And you go through some conic sections, we will use all these properties while we are deriving planetary motion.